So good morning all. Welcome to SAKALAVIDYA YouTube channel. Good morning once again. Welcome to SAKALAVIDYA YouTube channel. Okay. So today morning session we shall discuss on probability chapter. The probability chapter also one of the important chapter. Right. Good morning all. Good morning. Sunita Prakash, Kirtana, Suma, Didiya, Balu, Swati, Vaibhav, Ishwar, Narla, Vamshi, Govind, Chandana, Swati, Pavan, Praveen, Supraja, Balu. Right. Lakshmi Bhai. Right. Prasanna Hani, Abhi Prakash. Okay, let us wait for 3 minutes. So after that we will start the session. Sridevi, Motapelli, Vishnuvardhan. Good morning. Murthy. Fine, 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 fine. So today no Zoom interaction. Okay, Avinash. Okay, might be offline here. Ramaya Katakam. Okay, first I will discuss the concepts of probability, then I go for the problems. The problems also will be slowly, the levels will be increased, but you don't expect at a time level 2, level 3 problems today itself only. Okay, but you need to concentrate more, so don't discuss other matters in the chat box, better concentrate on the class itself only. Okay, Akshita Cheti. Definitely there will be one more Zoom that will be planned next Sunday. Next Sunday. Okay. Combination has been completed. Combination has been completed. Complex number evening session we have. One more session is there. Two. I think there may be 4 or 5 sessions are to be conducted for complex numbers. Karthik, Sudha, Okay, mock test. Deepti. Avinash, you have hurry. 9:30. Okay, let us start. Let us start. Okay. First, let me complete this chapter, then I go for theory of equations. So if I complete all the chapters, others are copying and they are posting there in their YouTube channels. That's why I need to take care. Okay, first probability. Part 1. 2 to 3 marks. Right. First, what is meant by random experiment? Random experiment. What is meant by random experiment? Anybody? What is meant by random experiment? What is meant by random experiment? What is meant by the random experiment? Okay. An experiment which has following two features is called a random experiment. Random experiment. An experiment which has following two features is called a random experiment. So what is the first feature means? The first feature, the results the results the results of the experiment are known well in advance. This is first feature. Second feature, the result of the specific performance cannot be predicted. cannot be predicted or expected. So any experiment which has these two features is said to be a random experiment. So that means now I give one example. So before going to toss the coin, we know the results. That means head or tail may turn up on the dice. While tossing the coins. That means results are known, head or tail. But if you conduct the same experiment in the similar conditions for 100 times, after that if you are asked to what is the result will you get after without performing 101th result means you cannot expect it. So that's why those kind of experiments are called random experiment. Sometimes the random experiment may be called as random experiment random experiment. Random experiment is also called as mathematical experiment. Mathematical experiment. Mathematical experiment. So what are the examples for this random experiment means? Tossing a coin, tossing two or more coins, rolling a die, selecting a card from a pack of cards, or selecting a ball from balls. Okay, now that means let us go for the examples now. Examples for random experiment. Examples. Tossing a coin. Tossing a coin. Second, rolling a dice. Selecting a ball from a bag or urn. Selecting a number from numbered cards. These are all the examples for the random experiments. Random experiments. Understood now? Tossing a coin, rolling a dice, and selecting a ball from a bag or a urn, selecting a number from a numbered cards. So that means now the next term is sample space. Sample space. Sample space. So what is meant by the sample space? Yes, drawing a card from a pack of cards also comes under random experiment itself only. Random experiment itself only. So sample space. So what is the sample space? So sample space means the set of all possible outcomes or results of a random experiment is called a sample space. A sample space denoted by S. S stands for sample space. The set of all possible outcomes or results of a random experiment is called a sample space. Generally, we use the set notation for this even probability chapter also. So that means, let me give one example now. First example, when a coin is tossed at random, then S is equal to, sample space is equal to head, tail, H comma T. That means H stands for head, T stands for tail. So when a coin is tossed at random, what are the possible results or outcomes? Head or tail may come up. That means if you make a set, this S is called sample space. S is equal to H comma T. For example, second example, when two coins are tossed, at random, this word need to be used. At random, the sample space S equals to head or tail, sorry, head, tail, head, tail. This is the when two coins are tossed, the sample space is this one. For example, when a dice is rolled at random, the sample space S equals to, dice means actually we have 1 to 6, 1, 2, 3, 4, 5, 6. When a dice is rolled at random, dice means I use for your singular itself only, singular. Die or dice is same, but in general now present in old textbooks actually they are using die word, but now it has been changed to dice. Dice is singular, plural. So now fourth one, when two dice are rolled at random, then S is equal to 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. This is the sample space. When two dice are rolled at random, then sample space is given by this one. There are actually absolutely correct. There are 36 because actually here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6 ja 36. There are 36. Okay, why should we write like this? Means we have one logic is there in this one. I will explain after that. So generally you may think that why sir actually writing all these things, means we have the so many shortcuts. Actually we can frame tips can be learnt with the help of this one. Understood now? So whenever if you are asked to write, you need to remember like this. Two dice are rolled at random, then the sample space you need to remember like this. Okay, next. So now, pack of cards. We talk about pack of cards. So a pack of cards is consisting of 52 cards. 52 cards. 52 cards. This 52 cards is divided into two types. Two types. So red cards and black cards. Again this black cards into two ways. Red cards into two ways. Okay, now this is 26 red, 26 black. Here this we can write this is club card, this is called spade card. So this is heart card, this is diamond, this is heart, this is diamond cards. So total actually we have so this will be A 4 aces, next 2 dash numbered cards will be up to 10 only. 10 okay, next K Q J. That means actually K, Q, J. These are how many? 12 cards. 12 cards. They are called honored cards. Honored cards. Next, this 2 to 10 is numbered cards. Okay. 2 to 10 are called numbered cards. Right. So this is the pack of cards. Total how many numbered cards are there? Actually 2 to 10. 2 to 10. That means total 9. 9 plus 4, 36 numbered cards are there. 36 numbered cards. 12 honored cards. Okay. This heart is 13. This also 13. This also 13 cards. This also 13 cards. That means heart, diamond, club, spade. Each is called shoot. Each is called shoot. There are 4 shoots. 4 shoots. In each shoot we have 4 cards. Okay. Next, event. One example. Getting an even number. Getting a prime. Third, getting a number less than 2. So these are all actually called events. Getting an even number, getting a prime number, getting a number less than 2, all these are called actually events. They are the subsets of actually sample space. So even just we have discussed regarding the dice, even we can discuss for any random experiment, we can discuss for any sample space. These are the examples. Next, equally likely events. Equally likely events. Equally likely events. So equally likely events means a set of events. A set of events. A set of events is said to be equally likely events if there is no reason to expect one of them interference to the others. For example, so that means actually here equally likely events means there is a same chance of happening of the events. That's also we can say that same chance of happening the event. Chance, we discuss about the chance itself only, not probability. So later we discuss probability also. The set of events is said to be equally likely events if there is no reason to expect one of them interference to others. So examples we can discuss. Examples: event of getting an even number when a dice is rolled. That means the event of getting an even number and event of getting an odd number have the same chance. That's why they said to be equally likely events. And also event of getting a head when a coin is tossed at once. The event of getting head and event of getting tail both have the same chances of happening or occurring, we say that. So they said to be equally likely events. So next is mutually exclusive events. Mutually exclusive events. So mutually exclusive events means a set of events is said to be mutually exclusive events if happening of one event prevents the happening of the happening of any of the remaining events. That means a set of events is said to be mutually exclusive events if happening of one event prevents the non-happening of the other happening of the any of the remaining events. That means, for example, when a dice is rolled, for example, occurring of, happening of, or getting prime number. Getting prime number means actually it prevents not to getting other remaining events. So that means example is here actually getting a even number, getting a prime number, getting a odd number. When actually here a coin is tossed at once. That's also example we can take it. So otherwise we can define mathematically also. Suppose let us say A is equal to getting an odd number. Let us say B is equal to getting an even number. When a dice is rolled at random. So that means getting an even number means you can write like this. Getting even number means when a dice is rolled 2, 4, 6. Getting an even number, odd number, this is B. Getting an odd number is equal to 1, 3, 5. Now see, If you get the even number, you will not get odd number. If you get an odd number, you won't get B. That means mathematically you can test one thing. A intersection B you find out. A intersection B is equal to pi. Nothing, no element is there. Then just like disjoint sets, if A comma B are any events, then A intersection B, their intersection B is null set, then A comma B are called mutually exclusive. Mutually exclusive. That means it can be extended like this. Suppose let A1, A2, A3 and so on dash dash AN be the events in a random experiment. Such that A1 intersection, A2 intersection, A3 intersection and so on intersection AN is equal to nothing, pi. Then this A1 comma A2 comma A3 comma and so on AN are said to be mutually exclusive. Mutually exclusive events. Mutually exclusive events. So mathematically you can remember like this. Okay. Now classical definition of probability. Classical definition of the probability. Classical definition of the probability. If there are n mutually exclusive equally likely elementary events. Elementary means further they cannot be split, that's all. Elementary events in a random experiment and m of them out of n, m of them are favorable to happen event E, then the probability of E is denoted by P of E and defined as P of E equals to m upon n. So this can be restated like this. So probability of E, P of E is equal to number of favorable cases for E upon total number of outcomes in random experiments or results. The number of favorable outcomes for E can be written as n of E also in set form. Number of elements present in E, cardinal number or order of E. But total number of outcomes means actually the total number of outcomes is related to the sample space. So that can be written n of S. Simply the probability of E equals to, you can remember like this, favor by total. This is the probability of any event. So favorable by total. Number of favorable cases for E upon total number of outcomes. Okay, now here, so can we find out number of unfavorable cases for E? Yes, why not? Actually, if you check here, this m is the number of favorable cases out of n. So that means now number of unfavorable cases for E equal to, that we can write n minus m. So probability of not occurring E bar also we can find out. That is probability of not occurring is P of E bar. P of E bar is equal to, you can write n of E bar as per the definition of the classical definition, n of S. Here n of E is n minus m upon n of S is total n. This can be written as 1 minus m by n. So actually this is m by n. So m by n is replaced by P of E, 1 minus P of E. That means probability of non-occurring event E is equal to 1 minus P of E, we can write it. So that means now you can remember P of E plus P of E bar is always 1. And one more thing we can discuss here, probability of any event. Here number divided by number, always you get positive itself only. That means probability of event will be like this. Since here P of E equals to m by n, so what are the cases will arise here? Let us discuss. P of E, for example, suppose m is 0, P of E becomes 0. Suppose m equals to n, the P of E becomes 1. But actually here P of E will be less than or equal to 1. That means this case occurs when m is equal to 0. It occurs m is equal to n. It is m is less than n. So m cannot be greater than n. M cannot be greater than n. It won't be possible. That means probability of any event lies between 0 to 1 itself only. That means we can write 0 less than or equal to P of E, P of E less than or equal to 1. That means P of E, probability of any event minimum value is 0. Probability of any event maximum value is 1. 0 or 1, or it lies between 0 and 1. And moreover, P of E is always positive, greater than or equal to 0. Right now, here now, if P of E is equal to 0, then E is called impossible event. Impossible event. Next, P of E equals to 1. E is called certain event. Certain event or sure event. Sure event. Okay, these points you need to remember. Okay. Always we can say that P of E is a maybe proper fraction. Proper fraction. It cannot be, is not improper fraction. Improper fraction. Right. Next important concept is odds in favor of an event. Odds in favor of an event. So how to find out odds in favor of an event? In Telugu, what we can call it as adrustamu. Adrustamu we have duradustamu also. So that can be calculated. We can quantify that luck, or we don't have any luck in favor of us. Luck is not in favor of us also. We can be quantified with the help of the probability quantification. So what is the quantification of favorable to favor to us an event? So now we know that as for the classical definition, we know that P of E equals to M by N, and number of favorable cases by total number of cases. P of E bar also we can find out. P of E bar is equal to 1 minus P upon N. That we can write N minus M upon N. Okay, let us write like this better. You remember. M by N means you may get confusion also. Okay. Okay. I discuss in another way. Okay. Let us suppose P of E is equal to probability of getting an event E equal to A by B, say condition A is less than or equal to B. Then you can find out P of E bar. P of E bar equals to 1 minus P of E. So P of E bar becomes 1 minus A upon B. This will be B minus A upon B. So now we can find out P of is to P of E bar. So that is equal to A by B upon B minus A upon B. This B gets cancelled. This A is to B minus A. This is called odds in favor of an event. Odds in favor of an event. Very simple. This you remember. P of, this can be remembered like this. P of E is to P of E bar. The ratio between happening of event to the non-happening of the event is called odds in favor of the event. Odds in favor of the event. So similarly, we can write now odds against the event. So let P of E equals to A upon B. P of E bar is equal to, we know, 1 minus P of E, whose value is 1 minus A upon B. That will be B minus A upon B. Now find P of E bar is to P of E. That is B minus A upon B is to A by B. B gets cancelled. This B minus A is to A. That means this is called odds against the event. Odds against the event. Okay. Suppose if odds in favor of E, in favor of E is A is to B, then P of E equals to see the P of E equals to, we need to write like this, A upon A plus B, right up. Next P of E bar. How to write P of E bar? P of E bar also we can write, that is actually B, second term, B upon A plus B. That means odds in favor of E is given. We can find out even probability of happening event, probability of non-happening event. So you can check here. We can check it now. If you add these two, what do you get now? A plus B by A plus B, you get 1. Understood now? Right now. So in the similar manner, if odds against E is A is to B, then P of E equals to B upon A plus B. P of E bar equal to A upon A plus B. These are the important points to be remembered. Right. So next, axiomatic approach. Axiomatic approach to probability. Axiomatic approach to the probability. So this was actually developed by the great Russian mathematician whose name is Kolmogorov. The credit goes to Kolmogorov. After that, actually, the total probability chapter has been developed, having been actually introduced the axiomatic approach to the probability. So what is the axiomatic approach of the probability? Let me discuss. Let S be the finite sample space. Finite sample space. Finite sample space. A real valued function. Real valued function. A real valued function P from P of S, that means power set of S to set of real numbers is called a probability function. That means function is defined from subsets of S2, possible subsets to real number system. Then that is called a probability function if the first one is P of E is greater than or equal to 0 for every A subset are equal to S. That means already we checked the probability of any event is positive. This is called axiom of positivity. Axiom of positivity. This is called first axiom. Axiom means this is actually self-evident truths. They cannot be proved. Axioms. They cannot be proved. Only statements. For every A the subset of S, this is E. E is the subset of S, then probability of any event is always positive. This is called axiom of positivity. Second case. Probability of sample space is always 1. This is axiom of certainty. Axiom of certainty. Axiom of certainty means actually probability of certain event is always 1. Next, third one is very important. This is very important. Probability of E1 union E2. E1 union E2 is equal to P of E plus P of E2, provided E1 intersection E2 is equal to pi. They are mutually exclusive. This is actually axiom of union. So that means very simple. Whenever actually mutually exclusive events are there, so we can apply this formula. That is called axiom of union. So if it is follows like this, then P of E is called probability of E as per the definition of the axiomatic approach. Probability of E, event E. So this is the axiomatic approach of the probability. How many axioms actually here we have? 3 axioms. One is axiom of positivity, axiom of certainty, and axiom of union. The union can be applied whenever the actually events are mutually exclusive. You remember. So based on this, total probability will be governed. This is very, very important. Generally, we will avoid this one. We need not avoid. So with the help of this axiom of union only, addition theorem of probability will be developed. Next, addition theorem on probability. I don't go for the proofs. The proofs will be based on axiomatic approach only. Addition theorem on probability. If A comma B be any two events in a sample space then P of A union B equals to P of A plus P of B minus P of A intersection B. That means probability of happening at least one of the events A or B. Union means A or B. P of A or B is equal to P of A plus P of B minus P of A intersection B. A intersection B means both will occur. It may be extended for even, for example, A comma B are mutually exclusive. Simply we can say P of A union B is equal to P of A plus P of B. So next write down point. If A comma B are two mutually exclusive events, then P of A union B is equal to P of A plus P of B. Reason, A intersection B is equal to pi, impossible event. Probability of impossible event is 0. Already we had a discussion. That's why we get P of A plus P of B. Okay, next we can extend for even 3. If A comma B and C are any 3 events in a sample space, then P of A union B union C equals to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. Just like N of A union B union C itself only. Okay. If A comma B comma C are 3 mutually exclusive events, then P of A union B union C is equal to, very simple, only these three we get, P of A plus P of B plus P of C. Right? Conditional probability. First, conditional probability. This is very, very important. Conditional probability. Anybody, what is meant by conditional probability? 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 You can chart. You can chart through the chart box. Independent events is different. We will discuss later. Suppose one event occurs after the occurrence of other event, then that is called conditional probability. Conditional probability. So that means the event of happening affects the happening of other event, remaining event, that is called actually conditional events. Their probability is called conditional probability. Right. So let's have a discussion for this one. If A and B, if A and B are two events in a sample space, and P of A does not equal to 0. That means P of A should occur. P of A does not equal to 0. Then the probability of B after the event A has occurred is called the conditional probability of B given A is denoted by P of B conditioned on A. Now the P of B conditioned on A defined as P of B conditioned on A equals to N of A intersection B by N of A. N of A intersection B by N of A. Here N of A intersection B both divide by N of S. You can write probability of A intersection B both can occur upon P of A. Similarly, sometimes you may define P of A conditioned on B also. That is equal to P of A intersection B upon P of B. So this is the conditional probability definition. So with the help of this one, actually we can find out multiplication theorem also. Multiplication theorem. Multiplication theorem means actually addition theorem is P of A union B. Multiplication theorem means P of A intersection B. That is multiplication theorem. So now multiplication theorem. Multiplication theorem. So multiplication theorem. Multiplication theorem. See, we know that P of B conditioned on A is equal to P of A intersection B upon P of A, provided P of A does not equal to 0. Cross multiply. P of A intersection B is equal to, we get like this, P of A times P of B conditioned on A. Or we can state P of A intersection B is equal to P of B times P of A conditioned on B. This is called multiplication theorem. Multiplication theorem. We shall have some observations here. What are the observations means? Suppose P of B conditioned on A. P does not affect on happening of P has not been affected by means of A. That means P of B or P of A conditioned on B equals to P of A. So then A comma B are called independent events. Independent events. Independent events. So this remember, independent events. One more important points. Suppose if A comma B are independent events, then P of A intersection B is equal to P of A into P of B. Its converse is also true. Converse is also true. Okay. If A1, A2, so on dash dash AN are independent events, then P of A1 intersection, A2 intersection and so on intersection AN is equal to P of A1 times P of A2 times and so on into P of AN. This is the property of the independent events. Independent events. Next we have complementary events. Complementary events. Complementary events. So for example, let E1, A1, A2 and so on, AN be the events such that A1 union A2 union dash dash union AN is equal to sample space, and A1 intersection A2 intersection and so on intersection AN is equal to pi, then A1 comma A2 comma dash dash AN are called complementary events. In particular, complementary event of E denoted by E bar or sometimes E dash also. Since E union E bar is equal to S sample space and E intersection E bar is equal to pi, and moreover P of E plus P of E bar equals to 1. Already we had a discussion on this one also. So these are called complementary events. So independent events and complementary events also we have discussed. So next, Bayes theorem. This is very important. Definitely one question will come from Bayes theorem. So what does mean by Bayes theorem? Anybody? Okay. Let A1, A2, A3, so on dash dash AN are mutually exclusive and exhaustive events. Don't get confusion. Exhaustive events means their union becomes yes. Exhaustive events in a sample space and E is another event. Such that P of E does not equal to 0. Then P of AI conditioned on E equals to P of AI multiplied by P of E conditioned on AI upon sigma I is equal to 1 to n P of AI, P of E conditioned on AI. Okay, this is the actually Bayes theorem. So don't worry, you need not remember the Bayes theorem. You leave it the Bayes theorem now. Okay, in simple manner without having formula also we can solve the problems. Don't worry, but the formula, whenever any concept based question is given, you need to remember that's all. Formula for your sake, for the revision. So far we have completed total concepts in probability. Okay, now I will switch over to the, once again I will go for two dice problem. Let me go for the two dice problem. I will check where the two dice problem. Yes, exactly, we got it now. I already told you. I discuss later. Now I will discuss. Look at the screen, all of you. Look at the screen, all of you now. See, when two dice are rolled at random, then S is equal to. Here we can write N of S is equal to, on first die 6, second die 6 ways. Permutations and combinations. 36 you will get it. So total number of outcomes in a random experiment is 36. So now here one logic you see, check. 1 plus 1 is 2. 2 plus 1 and 1 plus 2 is 3. 3 plus 1, 2 plus 2 and 1 plus 3, 4. 4 plus 1, 3 plus 2, 2 plus 3, this is 5. 5 plus 1, 4 plus 2, 3 plus 3, this one 6. 6 plus 1, 5 plus 2, 4 plus 3, 3 plus 4, 2 plus 5 and 1 plus 6 is 7. 6 plus 2, 5 plus 3, 4 plus 4 and 6 plus 2, 8. See, very logic. This is 9. This is 10. This is 11. This will be 12. That means sum of the numbers is actually 2 to 12. So that means actually sum of the numbers called score or total. That means getting a score 2 is only one possible case, 1 comma 1. Getting score 3, 2 possible cases. Getting 4, 3 possible cases. Getting 5, 4 possible cases. Getting 6, 5 possible. Getting 7, 6 possible cases. Getting 8, now here 5 possible cases. Getting 9, 4 possible cases. Getting 10, 3 possible cases. Getting 11, here 2. Getting 12, 6. That means number of possible cases actually see. Getting some 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maximum score is 12. This is maximum. This is the minimum score when two dice are rolled. Minimum score. See, possible cases getting 2 is only 1. 2 minus 1. 3 minus 1, 2. 4 minus 2. 4 minus 1, 3. 5 minus 1, 4. 6 minus 1, 5. 7 minus 1, 6. Here danger. 13 minus 8, 5. 13 minus 9, 4. 13 minus 10, 3. 13 minus 11, 2. 13 minus 12, 1. See, 1, 2, 3, 4, 5, 6 increases and then decreases. So this is the actually concept of this one. I need to explain. I explained last. Understood now? I hope everybody will understand now. Everybody will understand. Now, How many questions you can complete here? 11 questions we can complete. That means probability of getting total 2, 1 upon 36. Probability of getting score 3, here 2 upon 36. Probability of getting score 4, 3 upon 36. And 4 upon 36, 5 upon 36, 6 upon 36, 5 upon 36, 4 upon 36, 3 upon 36, 2 upon 36 and 1 upon 36. Understood all of you? So this is the logic behind the question, actually writing in this order. If you write in this order only, you will remember all the problems. So within a nutshell, almost more than actually 20-30 problems we can complete with the help of this concept. Okay. Thank you one and all. Bye. See you. Have a nice day. So now we shall discuss the problems.